All right, let's talk today about rotations. In geometry, we have these things called transformations. And the third of our major types of transformations is what we call a rotation. And a rotation is just basically when something turns or spins or something like that. So, rotations. We know translations is when something just slides or glides or moves or shifts. And a reflection is when something has a mirror image of it. A rotation, though, is, like I said, when something turns or rotates or spins. What I want you to notice is that sometimes reflections and rotations look similar, but they don't look exactly the same. And I think you can see that. Look at the images of those two red apples. Notice they don't look exactly the same. On a rotation, it's not going to be a mirror image. It's not going to be symmetrical. The bite mark out of that apple isn't a symmetrical mirror image of the one. It's a spun around version of the pre-image. And you can also tell by the direction that little leaf is facing which one is a reflection and which one is a rotation. So that's what we see when we see a rotation. Oh my gosh, what in the world? Who is it? Okay. Oh, I guess that guy likes to eat apples. Well, okay, as long as this guy's here and hanging around, let's rotate him. All right, what you need to know about rotations is that we can measure them. Sometimes things can spin or turn a lot, and sometimes they can spin or turn just a little bit. If something does like a quarter turn, we would call that a 90-degree rotation. And if it moves clockwise, we would say it's a 90-degree clockwise rotation. So remember clockwise versus counterclockwise? Clockwise just means which way do the hands on a clock go? They go that way. So that's clockwise. Okay? Can you spin this image 90 degrees counterclockwise? Sure. This would be a counterclockwise 90-degree rotation. Okay, each one of those are like a quarter of a turn because 90 degrees is like a quarter of a turn. Could you do a full turn 180 degrees? Yeah, that would be a 180-degree rotation. By the way, if you go 180 degrees, it doesn't really matter if you go clockwise or counterclockwise because you'll end up in the same spot. These are all what we call angles of rotation. And depending on how much or how little the angle is, that tells you how much the pre-image is going to rotate to turn into a new image. So, you can also do a smaller angle of rotation like 30 degrees, or a larger one like 200 degrees. But most of the rotations that we're going to do are kind of common numbers like 90 degrees, which is a quarter turn, or 180 degrees, which is a half turn. If you did a half turn and a quarter of a turn and went 3/4 of the way around, that would be what we call a 270-degree rotation. By the way, all three of these rotations are clockwise, right? Now, these are kind of your most common rotations. You could also do a half of a half turn, a half of a quarter turn, which is like a 1/8 of a full turn, and that would be 45 degrees. All right, pretty simple. Now, the kinds of problems that you're going to do when you do rotations are going to be like this. You might have to rotate this shape. Now, when you rotate this shape, every point is going to rotate. So if it was in quadrant 2, now it's going to be in quadrant 1. And if you go another 90 degrees, then it's going to be down there in quadrant 4. And then if you do another 90 degrees, it's going to be in quadrant 3. And you could do a full circle 360-degree rotation, and you'd be right back where you started. If we wanted to rotate that whole shape, it would be different, and the whole shape would spin around each time. For instance, if you had a point, like this point, point A at -2, 4, and you wanted to see where would that point end up if you rotated this thing 90 degrees clockwise, just picture the whole graph rotating 90 degrees, okay? each quadrant would move clockwise, right? So it would be like that. So where would that point end up? It would end up exactly where you see it right now, but right there. So this would be our A prime if we did a 90-degree clockwise rotation. Okay, what if you did point A and you wanted to go 180 degrees, but you wanted to go counterclockwise? Again, can we just picture that this would be like going from that quadrant all the way down into the other quadrant down there, counterclockwise? Sure. All right, so let's see what would happen if we turn the whole graph 180 degrees counterclockwise. It would be like that. And so that would be where your A prime would be when you move the graph back. That's not too bad, right? What's going to really make this easier is when you do this on your own, if you actually physically move your page and turn your page or spin it around, it'll really help you see where these rotations end up. And that's pretty much all we need to say, except sometimes you're going to have to identify the number of degrees. So on this one, you can notice it goes from that quadrant to that quadrant to that quadrant, which would be 2 90-degree rotations. So it would be a total of a 180-degree rotation. Pretty easy, right? All right, that's all we got to do. So hope that all made sense, and we will work on this some more in class. See you next time.